maybe gradually go to something that is you know maybe a bit um I'd say maybe a bit like less basic. So just a moment. Can you see my screen now? Can you see my screen?
Yeah.
Yeah, okay. So yeah, so this is just like basic statistics understanding, and I mean it's not like there's nothing that will be said here that is like different from something that we already know. The reason why is because like the statistics around us, like we see statistics like every day. Maybe for instance, we might be um, like watching maybe football. We have like the league table. It's just an example of a statistic. For instance, like I mean, we could also be listening to the news and they'll be mentioning like numbers, like the number of this, like for instance, um, what is what is the population of Nigeria, for instance, like it's still some kind of statistic. So like there's nothing, it's just for us to like relate it to the business world. And as much as possible, I'll try to run away from terms so that it doesn't sound kind of academic, because in the real sense, like in the business world, it's not so academic, and the whole idea is to make it very less academic as possible. So first we have like some content. I mean, we have statistics, just the definition. I mean, the definition is not so important, but I mean, since it's just like, okay, we have to just have it, then it's there. Then we have like what is statistics and where do we use statistics, right? So like where where at what part of like a data science project are we using it? Like what different things do we do? Sorry, there's someone who's trying to get in. So like, and then we're now trying to see, okay, how. I mean, we're now looking at summarizing like data, and then we now talk about a few terms first before we now start like types of data, and then we now look at categorical values, and then we will just do a bit of summary with categorical values. Now this is just part one of like basic statistical understanding. Then we would have a part two after the GitHub like session. So so I mean, as defined by Wikipedia, statistics is the discipline that concerns collection, organization, analysis, interpretation, and presentation of data. In applying statistics to a scientific, industry, or social problem, it is conventional to begin with a statistical population or a statistical model to be studied. But we don't really have to pay so much attention to all these terms. But the most important thing is like it shows us that at least like and I'm still coming there, but it shows like statistics is kind of important in almost all the life cycle of a data project. We're still going to come there, but I mean, just move forward for now. So yeah, here we're already there as well. So remember, like the first time we had this conversation, like we kind of said like a data science project, like especially in the office world, especially like I mean from what I've experienced and maybe what I've asked around. So what usually happens, and like I would say let's just talk more about these two guys, the data scientist and then the data business analyst, or whatever. So here, like the beginning of the project, you're basically trying to like take your requirements. So you're taking, yeah, okay. For instance, you want to do a project. Maybe the project is you are trying to investigate a certain thing, or maybe you are trying to build a KPI. So before you can even start, you are going to first meet with the business and try to understand. Okay, what is the business like needs? Like, okay, what does the business need? to do this investigation, if it's an investigation, what is the business trying to understand, something like that, and then from there you try to understand your data requirements. So now, when you are building your data requirements, you're already using statistics to a certain extent, because part of the questions that you probably should be asking them is, okay, so for instance, if it's KPI, you can basically be asking them, how do we want to aggregate this data? And we are still going to come to aggregation of data, but like if you want to ask, how do we want to use like a mean? Do we want to use median? Do you want to, So here we are just basically like asking questions to start with. So when we are doing the data requirements, we are doing requirements gathering. So when we understand like, okay, this is what we are going to do in the data project or KPI, we can, at this point, we're already aware of, okay, the kind of data that we want to collect. Now, when we move to data collection. When you get to data collection as well, you still need to use statistics, because why? You have to know, like, for instance, maybe you're trying to collect maybe a certain data. In a much more complex way, like I will, when we get to the second part, I'll talk maybe more about like how we probably use statistics at this point. So like when we are collecting data, we need to like do some checks just to know that like the data is correct. So it's actually meeting what what we are actually supposed to be getting as defined by the business. So then we now go to data cleaning. When we get to data cleaning, here we are trying to identify, okay, maybe for instance, maybe there are some kind of outlier. So what is outlier? Outlier can be like some data that does not make sense to the whole group. And this data can skew the whole data set. So here we now have to think of, okay, how do we want to like even deal with this data? Like for instance, maybe we're supposed to like do the average of maybe the average age of people that studied in a certain university or polytechnic, for instance, and maybe it happened to be the year that a certain ex-president decided to go to that university, right? So I remember, like, we probably remember when Obasanjo decided to go to Obasanjo in that class is an outlier because he's maybe like 80 something years old. And if we do not handle Obasanjo's data properly, it will give us a wrong picture of the whole set. So this is where, like, at the data cleaning point, you are still using statistics again. Now, in the data storage, it's not necessarily like the real function of like, but also in the data storage, you still have to use a bit of statistics. Then you go to exploratory data analysis. This is like basically statistics. You are basically checking, like, you're counting stuff, you're doing like mean, you're trying to compare like what is increasing, what is reducing, and all this kind of stuff. So here it's just statistics. It's not like, it's statistics plus business understanding and trying to check different things. Machine learning is definitely statistics, as in it's filled with like statistics. And then even in visualization, like, you have to visualize with understanding like a bit of statistics to a certain extent, because then when you visualize, you're trying to tell the story to the person who is watching. And if you do not tell the story correctly, visualization is a point where you can mislead the business. Like, you can have an idea, but if you don't visualize it properly, then this is a problem. But visualization is a different topic that we have lined up, like, that we will obviously like get to. Then at the data presentation. So when you also present data, you are still using statistics, because when you are presenting data, you have to like, number one, you have to simplify the data to the listener, especially because like the people that you probably present the data for, they are not as like technically savvy as you are. So when you present data, you have to try to summarize data as much as possible, But when you are summarizing the data, you have to be very careful. Because then it's easy to just say something that is so ambiguous and lose the listener. So here, like, we will definitely, like, talk about this a bit to a certain extent. Then another thing that like keep that we might also talk about is like KPIs. So like, because also like statistics is used in KPI building. So KPIs are, and I'll just do like a little introduction, but I know we are still coming there. So like KPI is like, it's just key performance indicator. So key performance indicators are used to measure like how well something is being done, or maybe how well a certain part of a business is doing. So like, like there's a function. So there's a function, and then like there's a function that a certain business is doing. So for instance, now if it's like a grocery delivery store, you one of the functions that they do is like you order food from them and then they have to deliver it to you. So maybe they are trying to measure their performance of how long does it take for them to deliver. So this is like a KPI, because then they're trying to see, okay, maybe they can improve the way, like maybe it's taking too long or it's taking too less. So something like that. So at that point, they are using statistics. Even some of them do like surveys, like they'll just say, okay, like how do you rate maybe this app, for instance, maybe on Google Play Store, and then they aggregate everything with some kind of statistics as well. So statistics is like used everywhere. Then also reporting. Reporting is very similar to data presentation and maybe a bit of visualization. Reporting is one of the very important part of an analyst work and even a data scientist work, because like you might not have the opportunity to present to everybody, so you have to write some kind of text. So, or maybe you have to write a certain book or a certain paper. In the process, you are reporting the analysis that you have done, or maybe like the data science project that you have done. So in this process as well, you would have to use statistics to explain to the like people who are reading that, okay, like this is what happened, and the way you use the statistics is very, very important. So, and then obviously we use it for analysis, and then we use it for forecasting. So and then I will move to the next slide now. Okay, sorry. So here, this is called like the DIKW pyramid, basically. So this pyramid is just a pyramid of like how data is transformed for the business. So for instance, so the idea is, as an analyst, you are basically getting your data. You are here, you get the raw data, you get like data of everybody who maybe bought something from the business. Maybe like the business is selling like maybe groceries, for instance. Like here you are getting all the data, but you see, the thing about this pyramid is that the value of the data, it goes higher. The more you go higher, the more there is value. The more you come lower, the more the data that you have. So this part is just basically telling you the importance of summarizing data. Like this slide, that's just the idea of this slide. So the idea is you get like really, really granular data. You can get billions of rows of data. Like imagine a bank, for instance. Imagine like maybe N26, or maybe, for instance, maybe First Bank, for instance. They have like a lot of they have a lot of customers, and these customers are doing a lot of transactions. So now, like those individual data is not really useful for anybody. Like, it might be useful, yeah, maybe in some cases, like, because it might be useful maybe in some cases, maybe if you are trying to check one transaction or two transaction or stuff. But for those guys that make decision, like it's not useful for them. All those one row, it's not useful. So they need the information in a way that is very like aggregated like in a way that is just like one number. Usually they just want a very simple one number answer, like okay, for instance they say okay, how much did people deposit yesterday? Like they just want one number. They don't want like okay, this person came, dropped 100 euros, then the other person came, dropped 200 euros and all that stuff. They just want that one number. So now your work as an analyst is to find a way to like move from the hundred and billions of rows to that one number, and in between that stage where you are moving around, you might need to do a few things. You might need to like remove outliers, you might need to do some stuff like that, and then you get to that point where okay, you can give them one number. Or maybe it might not be just one number as well. Maybe they want to see like okay, last month how much did people save, and this month how much did people save. So maybe they want to do some kind of comparison. So this is where like data moves from data to actual information. So information in the sense that okay, people deposited a certain amount of money, and then so if they have like this information, so they now combine the knowledge like of that they have. You understand? Like maybe they already like have a knowledge that if, for instance, maybe people are making more deposits, they already have an idea of what maybe it could cause it. Maybe it could be that there's so much money in the system and people don't just want to like keep their money at home, or they don't want to do something like that. Or you understand? So they now combine that with knowledge, and then those guys at the top make like the decision of like okay, okay, this is what the bank is going to do, because like there's so much money in the circulation. They might decide to take some strategy. So this is how like data moves from the granular level to the information to they now combine it with knowledge, and then they now use it to come up with some kind of wise ideas like okay, this is the direction that we will take because of this data. So that's the idea of like the data analyst, the function of the data analyst, the data scientist, because it's like he's basically like these people are basically like giving some service to a certain stakeholder that is going to take a certain decision. So in between, as an analyst, it is very important that you use the best practices to get to your information. And then even though some of these statistics also have some, I would say they have some weaknesses. So even when you report to like your stakeholders, you also have to find a way to, like if you have taken a decision in the way you handle the data, you have to find a way to explain it to that person, like okay, so that the person does not like use the data wrongly. So I could give you an example. There is this thing that people normally say. They will say that the price of an average house is maybe 80,000 euros. For instance, they can say the price of an average house is 80,000 euros. And then another person can come and say, with the same data, can come and say the average price of a house is 120,000 euros. So then this can lead to like some kind of confusion, because one person just said the price of an average house. So the price of an average house is median. That's what it means. Like in the real, like anybody that's talking about like average, like when you say, not saying the price, the average price of the house is this. That will be an average. That will be mean. But if you flip the word and then you now say the price of an average house, so you see like this is where like reporting could really lead to like confusion. So if the person that we are talking to doesn't know how to like decipher that like statement, he will just take it as a mean, and the way he will like the decision he will take on that data is going to like it might have some kind of error basically. So then that's basically that. Sorry, there's someone who's trying to join. And so we'll go to the next slide now. So here we will now discuss a few terms. Yeah. So the reason why we are discussing these few terms is that we might these few terms we might use like a couple of times in when we are talking about like this, when we are talking in this journey. So we might have to use some of these terms. So I felt like, okay, maybe we can talk about it like before we go. So like we talk about data. So I mean, data is just basically like everything that like describes something to a certain extent. So for instance, my name is my data, my phone number is my data, my house address is my data, my age, I mean the amount I have in my bank account is also my data, like all this kind of stuff. So like data is basically everywhere, it's everything. Like, so you can name anything and that thing has a lot of data, because then you have something that it is describing. Now, what is the data set? The data set is just like, it's just a group of data that like has like a certain maybe use case, for instance. So for instance, maybe I decide to collect maybe data about the sales of maybe Ravi, for instance. I could collect certain rows of different things, maybe categories of the items that they are selling. I could collect the price. I could collect how much of the items that they sold. Like in this sense now, like that's like a data set. Like as long it's kind of a set of data basically. Then you have like sample versus population. Now, yeah, there's the sample and then the population data. So the sample data is a subset of the population data. I'll explain. So for instance, now you're cooking, for instance. You can see the whole food that you're cooking as the population. But if you decide to taste just a part of it, maybe because you want to like take, like you just want to like if maybe for instance maybe you have added like ingredients and all that stuff, so you want to use those ingredients to make a generalization of the whole food, whether it will be sweet or it won't be sweet, or maybe whether you have put enough ingredients or not. Then what you probably do is you take a sample of that food. So this is like the sample data. So usually they use sample data to, like when they are doing maybe some investigations, they use sample data to like do the investigation, and then they generalize based on certain advanced statistical methods. So for instance, maybe like they want to have an idea of how many people have HIV. You probably see all these things that they are seeing on the news, that they'll say someone like 1 in 5 people have like HIV or corona or something like this. So when they do all this analysis, they don't go and ask everybody, but what they do is they just have a way of sampling, and this is basically like the example that I made. Like you sample with just a little part of your food to have a generalized idea of, okay, the food is good enough or it's not good. So this is so at this point, like when they do this type of research, they just ask a few people the question, but they strategically do it. And this part we won't be going into it, but you can also look at it down the line. I mean, it could be something that we could look at, like how do they sample data. But one idea of like sampling, especially in the case of the food, is that when you when you want to sample, you probably stir as much as possible. So you can have like a random, and then you make sure like the ingredients go round, and then you have like so so the little part that you take is like representing the whole population. That is the idea. Yeah. So then you have like descriptive statistics. The descriptive statistics, we kind of also looked at this before. So where we were basically talking about like we are trying to describe something that happened in the past. So like if you remember, there's this chart of like the levels of difficulty and the value of like statistics. So like descriptive statistics is the easiest statistics, and this is what we will really focus on to I mean, today and in the second part of the statistical understanding. And then measurement, yeah, measurement is basically like we probably know it is like when you try to attribute some kind of, I mean, qualitative value to something based on a certain, metric or something like that. At this point, that there you're kind of doing some kind of measurement. So we will go to the next slide as well.
So, sorry if you don't mind, I have a question, but
So I mean, you could just take the question. We'll take the question.
okay. So my question is based on this aspect of data and data sets.
Yeah.
So maybe, perhaps, maybe there will be a time that maybe an organization doesn't have a particular data that they can rely on to maybe for some insights
Yeah.
somehow, and they now want to source the data outside to probably generate some or get to look at some KPI. So maybe do you want to talk about maybe you want to give us some insight as to what we have to note, especially when we are looking outside for some data sets that the company might be able to rely on for the KPI, especially when they are not generating the data.
So I mean, it depends on different like you know use cases. Like if it's a data that the company is not like maybe they are not collecting the data at the moment, then maybe they could get the data in different ways. Maybe right, like maybe you can get like a third party organization that maybe uses this data. So please, can you mute your microphone? Sorry. Sorry, I'll mute you. Sorry, I have to mute you. So basically, like data, they could actually get the data externally. Maybe they could like collaborate with a certain third party organization who's in charge of, you know, like I mean, there are some organizations now that maybe their own work is just to be doing market research, and then they can, you can actually reach out to these people, or maybe you could do like surveys. It depends on what exactly you're trying to do. Maybe you could do, if it's like a survey, you can do like a survey. You can ask, like you can reach out, like like what I just said in the case of sample and population. It depends on the kind of data, really. If you are trying to use it as a KPI, then it will make sense for you to find a way to start getting that data. If you're trying to use it as a KPI, because then you're trying to monitor it going forward. So it has, and also when you build KPIs, you build it to measure your business. Or maybe, well, in this case, maybe, I mean, usually if you're not the government, most likely you're not measuring like externally. But like if you are measuring your business, then you want to build like that data, you want to get it, like, so you are trying to build the data from the source, and then you want to get it like going forward. So in this case, yeah, this might be what makes sense. But I mean, it's a very, very flexible scenario, so there's no one answer to that question.
Thank you.
Yep. Thanks. So then we have like types of data. So really we have like, and I don't really want to go like really, really deep into like some other subsection of this, but the major types of data that we have is like the categorical and the numerical data. So in the categorical data, like the idea of the categorical data is just basically like telling you the quality of something. Like for instance, maybe, I mean, it's might not always be like the quality, but something that's just that you cannot really add, or that is not kind of numeric. Is so maybe it's telling you like the class of something. For instance, maybe the sex, maybe it could be male or female, the the address, maybe like the state where maybe the person is staying. This is also like categorical. Or maybe, I mean, we will basically see like the examples. Then the numerical is basically like numbers, like, so maybe like how much was sold, what is the price, what is the what is the age of something or something like that. Like, this is numerical. So, and then you have like, so the examples of categorical data. So here you have like different examples. So we see like name could be Alice, Mary, John. Place could be Germany, Berlin, UK, or Nigeria. It's just basically like naming something or classifying something. That's like a categorical. That's the idea. I mean, marital status, married or single, like identifier number. Now, this is also very, very important because this could also be like kind of confusing. So, the identifier number, for instance, even though it's a number, you cannot use it as a numerical data. So, because this number is an identifier, so it's equivalent to a name. So, even if someone's tax number now, you cannot there won't be any value of like using somebody's tax number to add to another person's tax number or to do some kind of calculation in it. It's just used to like identify the person. Also, like maybe some other identifier number in some organizations, they also identify like their customers or their staff by a number. So they could have a staff number or a customer ID number or something like that. So even though this is a number in a data set, you are supposed to treat it like a categorical data. So then you have like your gender, also the same thing, and then you have bins of continuous data. So these bins of continuous data is just basically like age group, for instance. What is like the age group? So because maybe for instance in Germany we want to say like we want to know, okay, like how many people do we, like what is the population? So you first come back and say it's 80 million people. And then you now want to now be able to tell, okay, like do we have more old people or do we have more young people? So in this case now, it won't make sense to count the number of 1 year olds, 2 years old, 3 years old, and count all of them down to 100. By the time you are presenting this data, the person that is reading the data will be, like completely like shocked, and the person wouldn't be able. So you have to now bin the data. So you can decide to take a bin of 10, a bin of 5, or something like that. So maybe now in this case you're counting the number of people between 1 to 18. So these people are like the ones that are not yet adults, or you could even say 1 to 10. Then you count the teenagers, then you count like 20 to 40, 40 to 60. This is like the bin. So when you create the bin, you already have like, this is a categorical value, kind of. So that is basically some examples of categorical values. But usually categorical values, you shouldn't be like adding them. So when you cannot add them, most likely it's a categorical variable, and you shouldn't like treat it like a numerical variable in that case. So these are just some examples, but this is not all the examples. I mean, it's countless. So in this part, we just look at some of those categorical variables and how you can maybe handle them. Now, I have some examples, but then I would now also now relate some to the business world. So this is like very simple examples, but then back to the business world. So assuming you do like this example here is just basically like, if you do like a how would I put it, like basically you have like a survey where you ask people that, do you own a cell phone or not? So like, and the answer is most likely yes or no. Nobody is going to, like in this case, you're not asking that how many cell phones do you have. If you ask like how many cell phones do you have, this will give you a numerical value. But you ask that, do you have a cell phone or not? So here is like yes or no. So here is a categorical, and then you want to see like, okay, how many people said yes. So in this, when you get this type of yes no data, to make sense of it, most likely you're trying to count like the number of people that said yes or no. Very much like an election. You're basically also counting like how many people voted for Mr. A, how many people voted for Mr. B. So this is one of the ways that you are treating categorical values. Usually in the business world, the business is like, for instance, maybe if your business is around like selling something, as an analyst, you are basically counting, okay, how many items did we sell this week, for instance. Yeah, this is part of the kind of things that you're counting. And then maybe you now split it into groups and you say, okay, how many, like, so maybe you know, it's an e-commerce, and then you now see how many children stuff did we sell, how many adult sections did we sell, how many like this. Then you're now counting, you know, down into the groups like that. So this is like one of the use cases of like counting categorical values. So it's also possible that you are adding them also at some point. There is a chance that, okay, maybe, I mean, you could maybe do a bit of addition. Maybe not, I mean, it's not like um, the likelihood, but maybe, for instance, if you have counted for last week and you want to count for this week, then when you count, you can basically add them together. So then we have like percentages. So if you notice, like, this is like the same example that we use for the counting, but the difference here is just like we represent them in percentages. I mean, we probably have an idea of how to calculate percentages. I mean, we will do like a mini project, but the idea of percentages is just basically like you have like, sorry, you have like this total, and then you are dividing, you know, the number of yeses that you get over the 10, and then you basically multiply by 100. So there you have your percentages, and percentages are very, very useful, especially when you present to like people who are very high level, because also when the numbers are getting so high, when you do your counting, it doesn't make sense to tell, like, you know, people, for instance, now in an election, if maybe 100 and 120,000 people voted, you know, or 120 million people voted, and you know, you have some kind of really, really, you know, numbers like that voted for Mr. A and Mr. B. So on a normal, we have an idea that, okay, Mr. A won Mr. B because he had more votes. But if you really want to tell how big the margin is, it's usually better to like say it in terms of percentages, so you can easily quantify something with a percentage, yet than to say it in terms of number. And it's also very good because it's relative. Because if maybe, for instance, maybe like, you know, say Obama won with 100,000 votes, for instance, he won with 100,000 votes, and maybe um Biden won with a certain number of votes, maybe like 200,000 votes. You know, you cannot really compare the 100,000 votes to 200,000 votes, that both of them, because it's happening at two different times. So, but if you take the percentage of their winning at different times, then it's comparable, because it's also possible that people didn't turn out for Obama's election, but then they turned out for um, Biden election, you know, something like that. So that's why it's very good to, you know, put it in percentages, because then it also helps the user to understand it easily. Like, okay, this is just one number, and the lesser the numbers, the better for um for the stakeholder usually. So here, I mean, another option of handling like categorical data is like counting bin data. Like we said, like bin data is when you take, like, you know, when you kind of, you don't want to say like go through like 1 to 50, like, and start counting how many people are 1 year old, how many people are 2 years old, and something like that, and then count to like 50. Like, it doesn't really help anybody. So one of the, I mean, ways that you can do that efficiently is to create bins. So in this case, you would see like they created some bins of maybe 1 to 5, like people that are between the ages of 1 to 5, how many of them is one person, you know, 6 to 10, you understand? And then he counted the age ranges. So in this case, it makes it even less, I mean, it makes it easier for the person who is like looking at the data to easily say, okay, majority of this, you know, country has most of their people between the ages of 26 to 30. It's easier for them to make that decision. Okay, so maybe if you want to uh, maybe take a decision, then the decision should favor that age group, for instance. So, it's kind of easier to understand. And also you can use your big data with percentages. Also, big data is also very good for KPIs, to be very honest, because for instance, one of the things that businesses might be measuring in some cases could be, for instance, maybe I kind of made an example of like a grocery store. So maybe the promise of the company is to deliver their service to you in 5 minutes. So, and this is where they kind of use a bin, right? So they can use a bin here and then also use like, a percentage, for instance. So now their promise is to deliver the service to you in 5 minutes. Then they look at how many times were they able to meet their promise, and then how many times were they not able to meet their promise. So then they can now do a percentage. Okay, we met our promise like 75% of the time, for instance. So, here they have created the bin. So they first look at all the time, that it took them to complete the service. Every time that they had to, give that particular service, they look at it individually. Then they now bin it. Okay, in this case, it's between less than 5. In this case, it's more than 5. In this case, it's less than 5. In this case, it's more than 5. Then they will now be able to say, okay, based on this data, okay, we can now summarize and say that we are meeting our promise maybe 75% of the time. So like all this type of little analysis is usually done by the analyst. Maybe you are doing the analysis, or maybe you are doing the KPI, you are building the KPI. So I think like these are some ways to handle like categorical data. And yeah, so we will take like the break here at this point, so that like then afterwards we'll be talking more about like the continuous data and no more categorical data, something like that. So I don't know if there will be any questions with this first part. No question means no answers mean there's no question.
Yeah, Yaku.
Yeah.
Thanks for the explanation. Yeah, my question is, I have like 2 questions.
Okay.
I don't know. So the first one is, what are the tools for summarizing the data? Is there a particular tools?
Okay.
And the second question is, you mentioned KPI, which is key performance indicator.
Yeah.
But I discovered that most of the companies, they usually mention metrics as well. So what is the difference between the KPI and the metrics?
So so first, like tools that you can use to summarize data is like extensive, right? You can use like virtually any tool that you use as an analyst, like SQL you can use to summarize data with Goodbye. Python you can also use to summarize data. You can use like Tableau, to also summarize data. Like, so basically the BI tools can be used to summarize data. In terms of KPI, we will definitely come here. Adapt at this point. KPIs and metrics are very, very much similar, like in terms of definition. You understand? So I will say they don't really have so much difference. You understand? They don't really have so much difference. Like, it's just maybe the terminology. So, for instance, like you could say it's key metrics, or the metrics. These are the metrics that we are measuring, or key performance indicators. Right? It's I mean, it's not exactly the same, but it's not far from each other basically, as well. But we will definitely get there. Does that answer?
Okay.
Yeah.
Yeah, thank you.
So yeah, I mean, maybe if there is no other question, then maybe Tochukwu can already take us through um, the repo. So because then the idea would be good that maybe we could use a data set like anybody, depending on whatever language you can use, we can get into like teams. So if maybe we have like for people that use R, for people who use Python here, or people who use like Tableau or Excel, we can get into different groups, and then we have like a certain data set for each group, and then we just do the first project, put it there, go down the line, do another project, put it there, like that, like that, like that, and then we're already building like a portfolio. So Tochukwu would take the wheel. So I'll stop presenting.
Okay. So, good day, everyone. I don't need to show my face, so yeah. So I'll just share my screen and yeah.